Hello, everyone. First of all, thanks to Gareth and team for giving us this opportunity to present some initiatives on Eastern. Okay, so I'll start with which one? Next one, yeah. Okay, so Eastern is the largest region in the network. So we have about 1/3 of the track on Eastern, and there are 4 routes: East Coast, Northeast, Anglia, and East Midlands. So today we are presenting 3 initiatives. So the first one is Doncaster visualization map for managing inspection and maintenance. So I visited Doncaster only a few weeks ago, like three weeks ago, I think. Yeah. So I was so impressed with Josh's use of Visio. So do all of you use Visio here? For your patrol diagram, yes? Okay, so I was so impressed because Joshua took it a step higher and then combined all the patrol diagram and formed a picture of the patch. And he then added layers into the patrol diagram, the patch, with all the at-risk areas like flooding areas, all the lubricators, all the patrol different types of patrol like train-borne inspection and manual patrol. So it was a very good system to manage the patch. So, so Joshua is going to present it today. And then remote monitoring of SNC. And at Doncaster, they were the first to use Connox sensors. I think it was for a year now. They have been trialing them. So, and the experience has been very good. So Josh is going to show us examples of what they use, the sensors, the output from the sensors for maintenance activities. So the last one is the Class 153 SNC inspection train, which Mark kindly present in detail. So what we're presenting here via Phil is the user experience, if you like, and we'll show some pictures of how we use it. Okay? So, Josh?
Thank you very much. Good morning, everyone. Thanks, Sinsin. So yeah, like Sinsin just mentioned, pretty much it is a schematic diagram of our entire patch, which you can see in the middle there. That's just the one view zoomed out showing the entire patch. So initially, I was an apprentice 7 years ago, and I got the grueling task of implementing PLPR, creating diagrams, BVI diagrams, PLPR diagrams, and then raising all the MSTs. And then I got involved with all the SINs, so SIN 184, which is all the boundaries, which were kind of whipped up fairly quickly. Now, I got pretty much to a point where we must have had 200 diagrams, and I was reviewing each diagram every time. So I decided I'll just try and put it all together. Identified the layer option, which was a big improvement, so I can turn things on and off when I like. So here's a couple of examples what I've put together. So the track IDs is the first one. So instead of looking at a table format, all the track IDs, every line, boundary to boundary are all there. You can turn them off, and then we can put track cats on with the line speed. So that's again for every single line, every crossover, the boundary, followed by the enum data. So what I did with SIM 184, after drawing all the boundaries, after actually going onto site with all the third party and TMEs and SMs, got the enum data, cross-reference with ellipse, see if there's any gaps, and then create a plan, which pretty much is in the middle of the screen, which everything is green. It's covered by, it's got an RST. Everything in red is a black hole. So we have to manually record that, and it's one of the key, pretty much, problems we have across the route, whereas if we get a derailment, it's usually a non-recorded track area. Now, that gives us full control of the patch. We can see exactly what's running where. And then I went through all the traces, looked where we was getting low speed, converted them into black holes as well, and then put them onto the diagram to pretty much give us a full assurance. Track inspection, I'll skip over because I'm going into that in detail, along with track components. Clearances are on there, All clearances we've got all up to foul, which prompts us to get some action plans in and some scope renewals. Renewals are in there. I'll skip over renewals maintenance plans because we're going into them shortly as well. IBJs and impact routes. So at the bottom, there's Doncaster Station. I pretty much put every IBJ in Doncaster Station on the map. With that, 3 types of pretty much, if we have a problem, track circuit issue, green, pretty much no problem. Red is a full lockdown. And yellow we can work around. OTM data, which I've got a slide for. Grinding and lubrication, I've got a slide for. Out of use track, pretty much just puts where if we've got temporary buffers, and I'll put the mileage of that buffer, and then we create MSTs around that. Overhead line coverage, just at the bottom, you can see it's everything in red is has overhead line, and then everything in grey, it doesn't. EWAT, so pretty much we have to represent, go through all our problem sites for an EWAT. We've just done one for hot weather yesterday. So I pretty much put all the trees where we've had issues before, where they've come down. You can see a little picture on there, that's 6,000 minutes delay. So it kind of prompts us to be vigilant in these areas and send additional resources out to these areas if we require them. And then the SM patch, which is pretty much my bugbear because I get a phone call, I'll be on call, and say who owns this patch. So it's just pretty much clear that I'll control have this, so they can see exactly where our boundaries are as well. For if we do have derailments, it's usually the call we receive saying, is this ours or DB Schenker's? So track inspection. So there's 3 keys I concentrated on, which is inspection in darkness is in grey, PLPR is in blue, and then the yellow is inspected in daylight. So it has full PLPR runs on there, and then it gives the assurance of the full coverage, because you can see to and from. And you can also see the areas in yellow. You can see the track that's inspected in darkness from a position of safety. So it gives that assurance of when you're patrolling Newark Northgate Station, you can see Newark South Junction and Newark Crossing under load. And then we can convert that back to the patrol diagram. And I just stuck a picture of Newark Flat Crossing in there with the FFU, because that's one key area which we obviously like to see under traffic. So again onto tracks inspection. So you can see on the top left, that's the toggle layer. So that's where I can turn layers on and off. So you can see there's ramp review, reliability, the ones we've just gone through. And then the track inspection overlaid with the track components. So you can see everything on brown is wood. And then I made sure that we inspected that in daylight because it poses the most risk. Obviously with the curve being one of our checked curves. So again, we can go through start to finish. And when we're reviewing these inspections, when we go through the annual review with the patrollers, patrolling maps, we can just cross-reference what's inspected in days and the frequency. So effective maintenance plans and renewals. So the entire patch has little trains on them and renewals. So we can see exactly what's happening where and what isn't currently covered. So you can see we've got renewals at Bridge 298, a tandem tamp at Retford, which is this weekend, S&C reballasting, and each one of those has a comment box which you can talk to. For instance, if I want to start talking to the SMs of a planning team, my comment is week 51, Saturday, Sunday, P-Way Grantham mechanical reballast, 2249s, and with the speed on. It also has an additional layer which is called a ramp review, so we can see what assets currently have plans, renewal plans against them, and then see if there's anything we're missing out. So if we overlay the components, and then with the ramp review, we'll be able to see if we've got any components currently with no plan, and then it can prompt us to get props in and have that discussion in the ramp review, rather than going through a full table of, yeah, these are your sites, it's CP7, and it gives us a view of how long we can last it for on an overall goal. Asset performance, the OTM management is all on there, so I can see exactly where we've tamped for the entire patch, and then highlights areas which I've tamped twice, which prompts, should we try a scheme, should we stone blow, and then has it got a renewal against it. Lubrication, I also highlighted the lubrication because I'd monitor all our defects. So everything in yellow is covered by solar hydraulic lubricator mat for the area, and in white it prompts us to get additional lubrication out there. So moving on to Conux. So just to give an overview of Conux, it started in Luton on timber. We was the first to trial it on concrete. We've got 8 units, 5 in Marshgate Junction. We've got 1 at Loversall and 1 at Tuxford, all on the East Coast Main Line. Areas where I decided to put them was areas in problem where we can't see under load, mainly in the Doncaster station, and then areas which we could see at the same time, so we could actually monitor how accurate these devices were, because obviously in the dubious, and we could check how accurate it is. So the first one is 2282s, which is quite surprising. So each dot on the graph represents a train, and you can see that dot is all clustered and it's stable. Now I actually pulled a tamping shift from this site once we had this installed. So that's what good looks like. And this is one on 2457s in Doncaster Station, which doesn't look as well. So this is what the vertical displacement, you can see there's 6 mil and above on the Conux data, and then 2 devices are fitted, one on the toes and one on the crossing nose. Now, the ones we fitted at Tuxford, we made sure we fitted it as close as the detectors as possible, because we had 200 grand delay. So that's where we decided to put that one, and then these ones were pretty much key areas around the crossing noses. So 2457s following maintenance activities. So initially we roll bell for crossings, no impact. The data that we get from this system allows us to see pretty much what effect we've had the next day, rather than waiting for a 4-week trace and then actually reviewing the data, picking this pretty much what speed it actually ran through, rather than getting a usual trace at Doncaster Station at 30 mile an hour through a station, so we don't know what it reacts at high speed. So you can see the big drop in manual repair, and then followed by a parallel tamping. So this is us repairing the crossing nose in the station at 2457 Bravas. It's showing our method of repair and then how long it's being evaluated for. So currently it's effective maintenance of 7 out of 60 days. So if we don't, sometimes we will see if we're going to lift and pack a crossing, it'll be ineffective after 1 day, and that prompts us to try something else, try a new method, whether it's chip-ins or we go for additional machines. That's a squad tamping we did at Marshgate Junction, a junction that's not been touched since 1998, and it prompted us, after us repairing manually, we're getting no work, and it helped us because with the wire heights in Doncaster Station, we had the limits of not being able to lift very much, but with this data behind us, it kind of prompted a little bit of a push with overhead line to get it over the edge, and which we did, and we did deliver it. We did 2 back-to-back shifts, 2 machines talking to each other, and an independent design, which by time delivered. This is Tuxford, so we could see how much we affected a track the day after we did a dig job there. Obviously it was stable until we touched it, which was because we did localise reballasting around the crossing noses, so you're going to get that initial impact. Now you can see the drop after tamping to go back to stable, and then on the next slide it just gives an overview with the data that Conux provides with the speed, the vertical displacement and the acceleration. You can see how it steps up and how it changes with the speed. So you can see from the reballast it jumps up, jumps back down, and then we've predicted to decline to go back to its original position. So not only does Conux provide the vertical displacement, it does the acceleration as well. So this is 2456 Bravas. So we had high acceleration throughout on that crossing nose. And then once we changed the crossing nose, the acceleration just dropped. So this is Tuxford. So we actually did a weld repair on this crossing nose, and then we got a phone call from Connox and an alert, which you can see is a little symbol at the bottom, to say the acceleration's increased, something's changed, and that's after we did a weld repair to squats, which initially prompted us to go back out to site and check it, in which we did and followed more maintenance work. And then at the bottom is just a graph of the tonnage. It shows on the tonnage for every crossing we've got these visitor. And I'll move on to Phil. Thank you very much.
What a brilliant speech, eh? Nice young man. Right, Class 153 S&C inspection train. Well, this is going to be a very small brief following Mark's brilliant presentation. As since it's pointed out, we're trialling this in Anglia, and as you can see from the diagram, which is kind of basic compared to Mark's diagram, it is cloud-based, so the information is stored off track and is available immediately for download at the depot level. What you've got here is the Ava platform or desktop, and how you would access the inspection is on the right-hand side of the screen. You can see rail inspection. Once you've located the mileage and the area that you want to patrol, you would click on that rail inspection, and that would take you to this desktop. As Mark pointed out, the addition of a 4-foot camera, as you can see, there's actually 5 images here. You've got 2 on the left, the 4-foot, and then 2 on the right. The cameras that sit over the rails, you have one sitting over the back edge and one's actually sitting over the running edge, and then you have the 4-foot to help bring all the images together, because that's something that patrollers are used to, is actually standing in the 4-foot. Unfortunately, I can't zoom in onto the images, but the clarity is quite good. It is HD, and as they pointed out, that it can run at night time, and it's got illumination at the little can't think what they're called, widgets on the right-hand side, where you can adjust the contrast and the brightness, and you will have to do that if you really want to try to eke out a little bit of detail in the rail head, because it's going to be important. You're able to put bookmarks, so if a patroller wanted to highlight something of concern that he wasn't particularly sure about, so he could present it to the supervisor or to the SM, he can do so. On the left-hand side, you've got a brief image of the infrared camera, which would highlight any hotspots if you so wish to want to use it. And on the bottom right-hand side, you've got an image of the location. All right, here we changed. This is a similar image. Unfortunately, this image is a little bit darker, but again, if you use the widgets, you can brighten that image. On the left-hand side, this is where you get the geometry. And like Mark pointed out, you may have an inspector or a patroller that's reviewing this footage that may be trained up to be able to identify certain characteristics from the trace. But if not, that aspect can be switched off, and supervisors or section managers could use that as in addition to their own patrolling. The one little thing I just want to say is that this is still under review at the minute, and they're looking at improving the way that an operator interfaces with the desktop, so that as you start to scroll through, because the image will go, you can go backwards and forwards and then zoom in, and we're looking at changing the keys at how you interface with this desktop. Right, the patrolling. So when a patroller or an inspector wants to view a section of S&C, once he commences, you can see the blue line that would indicate where the patroller has actually covered, and there's a little cursor, orange cursor, that would indicate that this is how far he's completed that patrol. It will give an indication at the end if somebody's actually walked the entire crossover and adjacent road, if there was that type of lead, to indicate that he's either covered 50% of the patrol or 100% of patrol. Now, some discussions were saying that whether or not if the images were fully recorded, that information would come in and say, well, only 50% of this patrol was covered. So the section manager could turn around and say, well, do you know what? We're not actually going to use the video footage. We really need to go back out there and inspect the track. So they will have that option, or they can use the available data to supplement whatever their patrol. If the patroller or inspector picks up a defect, he can annotate the image. This has actually been zoomed in, and he can put a little box and then pick one of the options he's got on there. It could be like a missing key or what have you, or he can type free text in there if he's unsure what he wants to put in. The basic visual inspection report. As you can see here, it doesn't look like the TEF. However, once the inspector's filled out any issues that he's found during his patrol, when it comes to print report, it will print out exactly the same as the patrolling report, with all the same comments. The only issue we have at this moment in time is if there's a change to the patrolling TEF form, how do we speed that up and get that onto the system in time so that it's viable? And this is a sideways view, and what we've asked for is 2 of the inside running edge cameras that we currently have pointing downwards is to rotate them so that they face the running edge, because we're using one of the patrollers from Shenfield who said that he couldn't see the running edge of the switchblade. So we've asked them to change the camera positions, and then they'll use the software to actually position them correctly on the desktop. How effective that's going to be, we'll have to see when it starts running. I think that's it, actually. Thank you. Oh, sorry.
Okay, thanks, Phil. Josh, so to conclude, I think technology, we need to embrace technology. We need to embrace technology to be efficient. And also with technology, work with the experts. Okay, like Eastern, we're working with University of Birmingham, Southampton, Leeds, with the IM program. You know, whoever can supply the technology, we try and trial them. But at the same time, we need to know clearly what the end goals are. And then engage with the end users as well to make it useful for them. And that's it. Thank you.